My height. Doyle, what's my height? 12. Good job. All right, so we got 12 in there. And 1/3 base times height. We're good. 400. I want to ask anybody. 400. Remember what we talked about yesterday? Now that we're doing volume, our units are cubed. All right, that was fun. Basic square pyramid. Now let's get more advanced. Regular pyramid, square base, guys. It looks just like we did with number one. It's the same square pyramid. Ooh, perimeter of this square base. Perimeter of this square base, 36 inches. Height. Now, everyone always asks me this, so let's clear this confusion up. If I want slant height, I'll put the word slant with it. If you just see the word height, then it's the height, the altitude. All right, if I want slant height, I'll write the word in. So this is just the altitude. Is 15 inches. What's your volume? 1/3. We'll talk about capital B in a second, times 15. All right, so what is the area of this square base? If you know the perimeter, all sides added up is 36. Before we get to the area, can you find a side? Because it's got to be length times width. All right, area of the base is length times width. So find a side for me if the perimeter is 36. Perimeter is 36, side length of, Aiden? 6. Be careful, watch your mouth. You're doing it, you're thinking area. Perimeter, all four of these sides added up gives me 36. So if I did 6, that'd give me 24. You're thinking area. Yeah, 9. All right, hold that thought to the next problem. So what's my area going to be for this one? Area of the base, Zoe? 81. Good. 81. So our volume here, 405. Where we got inches cubed. Perfect. Everyone all right how we're getting 9? Because I'm going to change it on you for this next one. All right, I got anybody, any history studs in the house here? Great Pyramid. Giza?
Giza.
What do we do this in global?
It's definitely Giza.
Is it definitely Giza?
Yeah.
Definitely Giza?
I don't think I've ever heard Giza.
Have you ever heard of these pyramids?
Yeah. No, yeah.
When?
We learn about these like every year.
Every year.
It's
Like what do we know about them? Where are they?
Egypt.
Okay, they are in Egypt. You got me there.
And Giza.
Giza? I'm not saying this has already been done. But hey, real quickly, take a look at these. Look at that, unbelievable. Look how tall that thing is too, compared to Tower of Pisa, Statue of Liberty, Big Ben. Huge, huge. Now back to the real question. I don't want that. I don't want that. That's what I want. Don't really add. There you go. Okay. I searched this third period, and this was the first video that came up. And who would have thought I would have found the most creepiest video on YouTube? I can't stop watching. I'm just gonna start teaching like that. We're good. We're good. Okay.
Sounds like Snape and Harry Potter.
All right. There you go. So, sorry about that. I know some of you might have nightmares later on, but yes.
Bro, you seem like the guy that like make those videos.
Yeah. So I should start teaching her of Giza. Maybe you didn't know how to say pyramid. He helped you out, I guess. I'm giving you guys the volume, huge volume, almost 2.6 million cubic meters, and a height, again, height, not slant height of 146.5. Now I'm looking for the side of the base. Side of the base. All right, it's a square pyramid. So let's start volume, 1/3 VH. Plug your 2.5 million in for volume. So 2,592,276 equals 1/3 base times your height of 146.5. All right, so we're going to end up solving for capital B. That's not my answer, though. Remember, when you solve for capital B, that's the area of that square. We're going to have to talk big time about, all right, if you know the area of the square, how can you get to the side? Because it's a little different than what I asked Aiden with perimeter earlier. So go ahead, solve for B. Don't round that sucker on me. Solve for B. And just make sure we're good. 53,000. Everyone getting capital B about 53,084? That is the area. All right, let's talk now. That's my area, not perimeter. So I don't want to hear, oh, divide by 4 to find the side. That's not perimeter, it's area. I got to do something else here. All right, so there's my area. And to find a side of the square, how do you get to the area given a square? What's the formula? Length times width, or base times height. And what do you know about those two values in a square? They're both the same. With me so far? So if you're going to multiply them to find the area, it's going to be x times x squared equals this 53,084. So what do I, not divide by 4, not divide by 2. What do I actually have to do to the area to find the side length? Take both sides. Both sides, Thomas. To solve for a side length, what do I need to end up doing in the area? Take the square root. All right, so that's what ends up happening here. And we get a side length of, rounded to the nearest meter. Let me know when you have it. Rounded to the nearest meter. Haley, when you have it. So 230?
Oh, yeah.
Nearest meter, yep, 230 meters. Good work. There's your side. Okay, pyramid down, cone to go. Again, on your formula sheet, it's 1/3 BH. But instead of B, we talked about this with the cylinder yesterday. Instead of the BB in there, what's the shape of the base again in this cone? That is a circle. So instead of seeing B there, that's why you guys see pi r squared. Understand where the formula comes from. And then times the height. All right, times the height. All right, two-part question coming up here. Find the area of the cone in terms of pi, then turn it into the nearest tenth for me. So 1/3 pi. Ooh, no radius there. But I'd like to know from somebody in class, what is the height you're going to use? All right, what's the height I'm going to use here? Because there's 2 on there. Which one do we need? Ooh, back to Haley. 15, good. 17 is the slant height. And everyone doing Pythagorean theorem to find the radius, which I don't have, so I can square it. We got 15 squared plus r squared equals 17 squared. When you have the height, let me know. Height. Gianna, when you have it. Sorry, radius. We already know the height. 8, good work. Yep, radius is 8. So in terms of pi, what are we looking at there in terms of pi? 320 pi cubic meters. And now rounded to the nearest tenth your volume. And I know, I get it. I'll fully admit that this is overkill that I'm doing this for part A. We already know the answer in terms of pi. And now I'm asking for it in nearest tenth. Here's why. We got a Regents in a month. All year long, if you ever made a rounding mistake on our quizzes or tests, I just took off a half a point. But when it comes Regents Day, we don't take off half a points. It's full points only. Okay, so I want to make sure we are solid in rounding to the nearest whole number, tenth, hundredth. Want to make sure we're good there, because the last thing I would need to see is somebody who should have got 100 got a 99. Actually, we don't need to talk about that. No, getting a 99 because you rounded wrong, right? Some of we're going for the 100 in here, right? Most of us going for the 100. No, okay, never mind. I hope you are. I think a lot of you could possibly get it. I said a lot, not all. Cassini, what do you got there? Rounded to the nearest tenth.
1,500.
All right, we got it. Good. All right, there's your basic cone. Hopefully you had fun with that. Let's get back to honors level now. Let me give you the volume. You find the diameter. Diameter! This formula doesn't have diameter. But it does have what? It doesn't have diameter, so how can I get diameter out of that formula? Okay, no, I'll tell you. Yep, never mind. I got to call on people for you to respond to me. Josh has the radius. So when you find the radius, Josh, what should you do with it?
Multiply by 2.
Oh, good job. Good job. Everyone substituting in 96 pi for the volume. We'll get to the radius. Height is 8. There it is. And lucky for us, once again, lucky us, we got a pi on both sides, so they can go. Don't have to worry about dealing with them. But now I'll let you guys go on your own and get rid of the 1/3 and 8, however you see fit. And then I'll ask for the radius length. Radius length, Amy? Oh, thank you. Yeah, 6. So now double it. We know the diameter is 12. All right. Any questions, comments, concerns? We got 2 big dog problems. First one we'll do together. The last one you'll do in your group. These are beasts. All right, as you read through all this, here's the bottom line on this problem. I got a cone I'm going to fill with water. How many of those cones full with water could I dump into the cylinder without it overflowing? That's my question. All right, so I'm going to fill each of the cones there with water. How many of those cones could I pour into the cylinder? Full cones, not partial cones. How many full cones could I pour of water into the cylinder without it overflowing? How do I know this is volume? A month from now, Regents exam, cafeteria, gym, we get this type problem. How do I know this is a volume versus a surface area? What are you doing with the water? Filling it inside, right? We're going inside the figures here. So yes, this is volume. I know there's no cubic units anywhere, but we got to fill it. So volume. So we got to find the volume of each first before we talk. So the cone and the cylinder both have different volume formulas, but again, you guys have formula sheets to figure out what they are. You're going to have to do a little work for the cone, right? Because 5 is the slant height, not the height you want to plug into the formula. As you do Pythag, everyone's finding the height of that cone is 4. And I'm pretty, yeah, I definitely did talk to you guys yesterday, at least, maybe not yesterday, but I talked to you about when you have pi in your formula, you don't need to write out the full decimal. If you don't want, you can leave it in terms of pi. That's fine with me. All right, you can leave it in terms of pi. I always write it out because that's how I roll, but. Okay, what do I do with these two to find the number of cups? And this is not an easy one to set up a proportion with, so I'm not going to suggest that. But again, 37.7, I pour into there. Another 37.7, I pour into there. How many times before we get to 351 or before I overflow here? What do I do with the two? What do I do with my 2 volumes here? Suggestions? What do I do with the 2 volumes there, Zeev? Divide them. Good. All right, I'm going to take the volume of the cylinder divided by the volume of the cone. Everyone's all right? Why we would do that? You multiply, and that's a whole bunch of cones, by the way. It's going to overflow big time. Now, let me talk about the answer here, because the answer, if you do it on your calculator, is about 9.3, right? 9.3. And I know we've talked paint cans. I know we've talked wood chips. Again, you're not doing 9.3 cups, plus it says full cups. Usually we've rounded up, right? Because 9 wouldn't cut it. But this problem's a little different, isn't it? I want to know how many full cups before I overflow. And if you go to 10 cups, it's going to overflow because the cylinder only holds 9.3. Anything more, we're tipping water out. All right, so that's why our answer is going to be 9 versus 10. Is everyone all right? I know we've been rounding up every problem, but this one we don't. If we do round up, we're going to overflow, and that's not what it's asking for. So 9 cups. All good? All right, you ready for this beast? You can do it by yourself. You can do it in your groups. Talk to each other if you want, but I'm not going to say a word to you. I'll just cover up my work. Just so you are going in the right direction here. I got a house here, or a room. All right, a room that's shaped like a house, I guess. Everyone see what it's made up of. On the bottom, what do I call that polyhedron on the bottom? That's a rectangular prism. Perfect. And on the top, that's a triangular prism. You're going to work with these things called BTUs, British Thermal Units. British Thermal Units. Type of energy. I don't know much about it. I don't even know if that's true what I just said, but and I don't have time to look it up again. So how many of those BTUs do I need to cool the house? Okay, and 2.5 BTUs for every cubic foot. So that tells me you got to find the volume of the room. All right, find the volume of the room and go from there. And I'm just going to stop talking from there. Go ahead. See what you can do here. This is a tough one.
No.
No, sorry, boss. That is correct. What are we doing here?
I don't know.
That looks correct. So what'd you do with that? What'd you do when you?
I think it's like
Okay. But also keep reading though. We need a little extra BTUs because we got 4 windows in the house.
yeah. Then you add. It's like the slime.
Did you add the 2 together here? Did you do the prism?
That's this.
It goes with it.
Should be.
Mr. Carlino.
1296.
Okay. Yep. You added them together, right?
1296
Yeah.
plus 3.
That's like 5 something.
4184. And you take
Times.
that
Yeah. Plus the $4,000.
Oh.
Is the
Yo, go ahead, Josh.
Is the 6 the like?
The 6 is the height of that triangular base, not the slant height. The height. Good question. Yep. The 6 feet is referring to the height of the triangular base, not the slant height. I think the toughest part about this one is finding the volume of the triangular prism. Rectangular one, easy. Triangular one, a little tougher. And this is like the 6 word problems on next week's test. This one would qualify as one of those types of word problems. Yes, because we got to do a surface area of a sphere tomorrow. But surface area figures we've already covered? No.
No, you will. But you won't. Yeah. You have to use 2.5.
If you're unsure, set up a proportion. 1 cubic foot equals 2.5 BTUs.
So that's the one.
Just like find the volume of this. It's just like find it.
Yes, it's fast.
Find the volume. Finding volume.
So you just add these.
Okay, you want to talk about this? Check it, even though if you're on to the homework already, let's check it. All right, rectangular prism shouldn't have been a big deal. 9 times 24 times 18, 3,888. No issues there. Okay, triangular prism, which is what I was concerned about. Triangular prism, it's still BH. So real quickly, you had to find the area of this triangle using 1/2 base times height. That's what I did up here. 1/2, the base is 18, the height is 6 of that face. Good? So that would have given me 54 for capital B. Now the height of the prism, I've been stressing this to you guys. The height of a prism is the edge that connects the bases. So this right here would have been the height of the triangular prism on top. And that height is 24. So that is why I have 54, which comes from this right here, 1/2 base times height, times the height of the prism, 24. And then from there, triangular prism 1296 for a total volume of 5,184. And it's going to go dead on me. Maybe not. Yep, of course. You multiply that by 2.5. Add in the 4 windows at 4,000 apiece. 16,690. 16,690 BTUs. Okay. You got to make sure you add in the 4,000 for the 4 windows at 1,000 apiece. Okay, 16,690 BTUs. All right. Questions? All right. That is what I'm talking about for next week's word problems. Let's get going on the assignment.